I'm Timotab, and today I'm going to solve Spotted Uranium Killer by rockratzero. Rockratzero currently has a Kickstarter live, and the Kickstarter is for a book of chemistry-themed puzzles. My understanding is that there will be at least 118 puzzles, which would be one for each of the elements in the periodic table that we currently know about. rockratzero is also a chemistry professor, and so is going to provide some history and facts about the elements as well. If you would like to try this puzzle for yourself, it'll be the first link in the description. There will also be a link to the Kickstarter page so that you can find out how to get your copy. All right, let us have a look at the rules. Normal Sudoku rules apply. So we're going to place the digits 1 to 9 once each in every row, every column, and every box. Digits on grey lines alternate between odd and even numbers. So if this were a 2, this would have to be a 1, a 1, 3, 5, 7, or 9. Digits joined by black dots must be in a 1 to 2 ratio, so one will be double the other. So if this were a 2, this would have to be a 1 or a 4, so that one of the digits would double the other. Digits contained within dashed cages must sum to the value in the top left corner of the cage. So those 4 digits will sum to 23. Okay, I am going to restart the puzzle to reset the timer, and let's begin. All right, I think we have some places to start with the dots. So, there are only a limited number of digits that can go onto a black dot. We can put 1, 2, 4, and 8 on, powers of 2, and we can also put 3 and 6 on. Now, I can't put 3 and 6 on here, because if I put 3, then 6, then this would have to be 12, but that's not valid. So this has to be from the 1, 2, 4, 8 group, and in particular, that digit is 2 or 4. These are from 1, 2, 4, and 8, and we will also have both 2 and 4 within that group. This is now 3 or 6. Down here, we have 2 and 4. Again, 1, 2, 4, and 8. I'm actually going to remove the corner marks because I should be fine. This is a 3-6 pair. We now have all the 3s and 6s that we are expecting in columns 7 and 8. So 3 and 6 must go in those cells. So this must be from the 1, 2, 4, 8 group. And in fact, this can't be 2 or 4 because we have a 2, 4 pair in the column. And now, if that's 1, this has to be 2. If that's 8, this has to be 4. And that tells us that this is an even digit. That's very nice. So I can start coloring these as even digits, which I like to use blue because that's a good contrast to orange, and orange starts with O for odd. All right, this being an even digit must be a 6. That's now 3, if I can type it correctly. That's a 6, and that's a 3. This must be from 2, 4, or 8. It can't be a 6. This can't be 2 or 4 because we know that 2 and 4 are in there. We know, in fact, that this is a 3-6 pair because I've got another black dot that has to be from the other set. So this can't be 2, 4, or 6. That must be 8. That makes this the 1, 2, 4 set. That makes this a 4, which makes this the 2, 4, 8 set. Okay. These are from 5, 7, and 9. That is 2 or 4. That is 2 or 4. This is a 3, 6 pair. This is odd. So that has to be a 1. That's the only digit that's odd from the 1, 2, 4, 8 set. So that's 2. That's 4. This is 4. And that is a 2, 8 pair. Very nice indeed. I've got an 8 there. I've got an 8 there. So that must be an 8. That resolves the 2 and 8 up here. These are from 5, 7, and 9. Okay, a 3-cell 15 cage can be either it can be 4, 5, 6, or it has to be one low digit from 1, 2, 3, one medium digit from 4, 5, 6, and one high digit from 7, 8, 9. Now, we can see that it can't be 4, 5, 6 because of this 6. The low, medium, high thing, let us suppose I took the two get my brain in gear. If it's not 4, 5, 6, then if I tried making this 1 and this have 1 and 2 in it, a better way. If I make it the highest digits it could be, 2 and 3 from the low set, then that would be 5, and the remaining digit would have to be a 10. So I can't have 2 low digits on it. If I make it have 2 high digits and I make them as low as possible, that's 7 and 8, that's already 15, and so I can't fulfill it. So I can't have 2 high digits on it. And if I try having 2 medium digits from 4, 5, and 6, then the other digit has to be the other digit from 4, 5, and 6, which we've already accounted for. So if it's not 4, 5, and 6, there is a low digit, a medium digit, and a high digit. So we know that the low digit must be 1 and 2, 1 or 2. The medium digit must be 4 or 5, and the high digit must be 7 or 9. So if it's a 1 on here, then I'd need 5 and 9. If it's 2, it'd be 5 and 9 because I couldn't do 6 and 8. If it's a 2, then I need 13, which would be 9 and 4, or 7 and 6, but I can't do 7 and 6 because of this 6. So 9 is definitely on here. I think that's right. Nine. Yeah, if I put 7 here, then I need the other 2 digits to sum to 8, which obviously couldn't be 1, 7 because I'm already using a 7. Couldn't be 2, 6, couldn't be 3, 5, and couldn't be 4, 4. Right. So yes, so 9 is definitely on here. So that is a 5, 7 pair, and now 5 is not on here. So 4 has to be. So 9 and 4 is 13, so that's 2, 4, and 9. That makes these digits, in fact, this would have been much easier if I had thought about it. These digits must be by this row 1, 6, and 3. But it was a useful exercise to think about that. These 3 digits then, well, if that's 5, 7, that's a 9. So these are 5, 7, and 1. And that one's not a 1. Okay. This sees 1, 2, 4, and 8. So this must be a 3, 6 pair here. That makes this a 1. These 6 digits sum to 23. And we know that the whole box sums to 45 because that's the secret of Sudoku. So these 3 digits sum to 12. No. 22. That's better. 22 is a much better number. So if that were 9 and 8, which is the highest I could be, that would be 17. That would be 20, which would, if that were a 3. So that can't be a 3. That has to be a 6. That has to be a 3. And now these 2 digits have to sum to 22 minus 6 is 16. And that has to be 9, 7. Okay, so that is not 9. Okay. By Sudoku, we know that 3 is in one of those. All right, this cage, I've just seen, we have a 9 here, so these 3 add up to 10, but it can't be, so 3 digits that sum to 10. Could it be 2, 3, 5? Yes, I think it could be. If it's not 2, 3, 5, then it has a 1 in it. Which means the other 2 digits would sum to 9, which could not be 1, 8. Could not be, it could be 2, 7. Could not be 3, 6. Could not be 4, 5. So 1, 2, 7 or 2, 3, 5. 2, 7 or 3, 5. So 2 is definitely in here, so that's an 8. That's a 2. That is not a 3 there. So it's either 2, 3, 5 or it's 1, 2, 7. Oh, 2 is definitely here by Sudoku now. So, oh, yes, because we've just figured out the 2 was definitely there either way. Never mind. So where does 6 go in this column? The only place for it is here. That makes that a 3. That makes this a 6. And this a 3. And now 3 is definitely in here, so it's 2, 3, 5. That 5 removes a 5 from there. This is a 1 or a 7 to complete the column. And the 1 tells me that that's a 7. That's a 1. That's a 5, 7 pair. All right, I have probably been neglecting the fact that that sees 2, 4, and 6, so that's an 8. This must be a 4, 6 pair. If this is a 6, then this is a 3, which it can't be. So that's a 4. That's a 6. That makes this 2 or 8, but it can't be a 2. So that's an 8. These are 5 and 9 to complete the box. That is 7 or 9. Can't be a 5. Okay. 8 in this row must go in one of those. This 8 is looking across. This is 1. This is 2. That is not a 2. That is a 4 or an 8. In fact, that 8 tells me it's a 4. That makes that a 1 and this a 4. And these are from 5, 7, and 9. That is not 3 or 6. So that actually becomes a 3-6 pair. And now that's 9. And in this 23 cage, we need 14 more. And that has to be a pair of odd digits. So that's going to be 5, 9. That makes this a 7. And this digit is a 1. This is now 5, 7, or 9. Okay. Right, if this were an 8, these two would have to sum to 2. They can't be. That's 3. These two now sum to 7. Can't be 3, 4. They can't be 6, 1. They must be 2, 5. And we know the order. This is an 8. This must be a 1. And that is a 4. And that does indeed add up to 13. Okay, this 3 is looking down there, making that a 6 and that a 3. This 5 is looking down, making that 7 and that 5. The 2 is looking down, so that's not a 2. And that's not a 4. Okay. 1, 7, and 9 fill in the box. This 7 is looking across. That's a 9. That's a 7. That's now 5 and 9. That's now 7 and 5. This is a 7. That is a 1-9 pair. That is not 7. So that's a 5-9 pair in the column. That makes that 7. That gives me a 5-9 pair here. So these two digits are 8 and 7. And we know the order. That makes this an 8 by Sudoku. One, 4, and 9 in the column. That's a 1. That's a 9. That's a 4, 2, and 9 here. That 2 removes a 2 from there. Okay. These two digits are 4 and 5, and I know the order. That makes this a 3, which makes this 6, and this 3. This is a 7. I need a 2 and a 6, which we know the order of. That makes this 5. This is 2. This one is looking across for a 9 and a 1. That 9 looks back over here for a 5 and a 9 and a 5 and a 9 and a 5 and a 9 to finish off. Another lovely puzzle from the previews of this Kickstarter. I really enjoyed it. In particular, I liked, I think it was this cell that I was able to prove early on must be even, which then gave me the parity of the digits on the line. Yeah, really enjoyed that. Thank you very much to rockratzero for it, and look forward to hearing good results from your Kickstarter. If you like this solve, then please hit the like button. You can subscribe to see some more, and I would love to hear your comments. I'm looking forward to next time. Be seeing you.